Hello everyone, welcome to my channel. I'm Dr. Dro. Today I'm going to show you how to compute utilization of your inventory using pyspark specifically. I will also show how to do it using Spark SQL, and this will give you a nice way how to know how your inventory, whatever it may be, is being used on a daily basis. I will show you a notebook I prepared, and I hope you will find it useful. Leave some comments below how you deal with it, and let's go right into the code. So, to start with, some basic imports here, and I am then creating a Spark session. These two comments here, I left them here, although they are commented out, as you see. This is some attempt I had to avoid some warnings that come occasionally later. Maybe we will see them during the run of this code, I don't know, because it's not happening all the time, something about garbage collection. Again, if you know something, leave some comments and we can further discuss it there. So now we have a Spark session spawning and ready to be used. Now, the data I'm working with is the following. Imagine that you have an inventory, in my case, 3 different items. The first field here is the ID, and for each item, we specify a date range, a start date and an end date, through which the item has been used, utilized. So here we see that item number 1 was used between January 1st to the 3rd of January. We can discuss whether it's inclusive or not, things like that. We will see a little bit of that in later. But this is just to give you a feeling how to work with this, and you might need to make some adjustments. Then also between the 8th and the 10th, item number 1 was used. For example, item number 2 was used between the 2nd and the 4th of January, and so on. Of course, this list can go much, much longer. And this is the data we have. So we initialize it, and then it's written here. Now, my purpose is to compute the utilization of my inventory on a daily basis. So to that end, if we look at the data here, then for example, on the, let's see, on the 2nd of January, both item 2 and item 1 were utilized. So that would be like 66%, 66.6, yeah, and so on, percent utilization. Just as an example, this is our objective. The first step is to find the minimal starting date and the latest end date. In other words, determining the full range of time that we want to inspect. And this is done like so. So indeed, the 1st of January till the 30th of January. This is, of course, just dummy data and an example, nothing serious here. Now, the main magic, so to say, starts to happen here with this statement, where what we create here is a list of all the dates, like 1 row per date between January 1st till the end of the date range that we're interested in. And this is how we do it, using here the explode method coming from the functions module of the pyspark library. And you see I just printed here the first 5 rows, January 1st, 2nd, 3rd, 4th, and so on. So far it doesn't look so interesting, but in the next step we make it interesting. So here we use the crossjoin, and the crossjoin does the following. For each row in our original data here, we explode it, we duplicate it, we multiply it for every item in the second table, in the dates. So in other words, now for this first row here, it will appear 30 times, each time for a different date, which I call current date. So this is kind of the running date. And maybe you can now imagine what's going to happen next. We're going to define a new column, with column. We use the with column function, and this used is essentially just looking whether the current date comes after the start date and before the end date. So in other words, is this falling between this one and this one? And is this falling between this one and this one? And this happens all over the place, right, for every row. And if we do this, we get, so here I just showed it as a pandas data frame, but under the hood I'm still using the Spark data frame, pyspark. And you see that indeed for this first row, it appears multiple times, but only for the first 3 cases, we have that the used is 1, because it's a flag, essentially, an indicator that this item for this contract, you can think about it as a contract, was utilized on this date, and also on this date, and also on this date. But then on the 4th of January, it was returned, so to say, no longer utilized, so it becomes 0. And this happens for all the cases, and you see we have quite a lot of rows. This maybe gives some hint why we call it the explode. And now we are ready to pivot, and the pivoting is just to show you a little bit how it looks like in a more condensed way. Here we have a row for each date. Each item has its own column, and you see exactly what's going on here, right? So for example, on January 14th, we had 100% utilization rate, which is really great, and all cases are 1. However, if we look here, so on the 7th of January, there were no utilizations at all, so it's a 0% utilization rate. Now, you may say that this is enough and we can work with this. However, imagine that you have millions of items, maybe books, maybe some hardware that you rent out, maybe, I don't know, whatever. And this can become very, very complicated, right? You get many rows, of course, for every date. So if you run your business or whatever for 5 years and you want it on a daily basis, you have a lot of rows, and you also have a lot of columns. This is something that can undermine the performance of whatever data processing you want to execute. So this is here with the pivoting. It's just for demonstration. I made another video with a little more details on how to use the pivot function. But now let's do the real thing. And you may say, so I remind you that now we have this data set, right? And you may think that you can now group by the current date, sum the numbers here, and this will give you, and count, sum and count, and then the division will give you the utilization rate. This is what I'm doing here, right? I group by the current date. For the used column, I do 2 aggregations. One is summing, so summing the ones, and this will give us the total use, and also counting the used. And if we do this, you see that it's wrong, actually, because it gets here, so it counts correctly how many items were used on January 1st and so on, but the total inventory is wrong. And it's wrong because if we go back to the way we started, we have here 8 rows, right? And for each date and each each combination of ID, start date, end date, and a current date, we will get duplications, and then there will be 8 rows, and this is the count per group. Yes, and this is the count we have here, and this is wrong. The way to fix it is, it depends. So the way to fix it may differ depending on your mileage. What I did here, I took the distinct number or the distinct IDs and counted them. So this gives us kind of the overall inventory over the whole period, right? But imagine that your inventory changes. So you have new items coming in, some items are retired. So every day you might have a different size of your inventory. So you will have to be more specific here and more elegant, but of course it's doable. Let me know again in the comments if you want to look deeper into this. We can do that, of course. And finally, the percentage is taking the total used, what we have here, and we divide it by the total, by the inventory. And we order by the current date, and voila, here's what I wanted us to have. So on day 1, January 1st, we had one item out of 3, so it's 33.3%. Then the next day, item 2 joined, right? The inventory size didn't change, so we went up to 66% and so on. This is how you do it using PySpark. Just to show you briefly, you can also do it using Spark SQL. To that end, I'm creating a temp view here, and we will use this SQL query here. It essentially doing the same thing as before. It's just in some cases, for example, if your data is already in Unity catalog, for example, on Databricks, then you might want to use the SQL query. Depends. I think in many cases PySpark is better because it's easier to test, for example. So you need to decide on your own. In any case, we create here, we find the minimal start date, end date, and then using the explode function here, we create this list, and then we explode it in, we do the cross join here. And if we run these two things together, then we get essentially the same result that we had before. For each row in our initial data, it is now will be available multiple times depending on the date range, and I assume from here you can take it with SQL, just adding the count and the sum. Again, don't forget to check what is the total inventory of your base. This is something that might cause you problems if you miss that. So that's the summary of that's all I wanted to show you. To wrap up, using what I showed you in this notebook, you can compute the utilization of your inventory. It's just the initial example. The main functions that we used here is the explode and the cross join. These two together help us do the magic here. We also mentioned that we can use a pivot, but we also agreed, I hope, that the pivoting approach is not suitable for larger data sets because of the number of columns and the number of rows. Yes, you're right, with the explode approach, even if only with the explode approach, we will have a lot of rows. That's true. But this is something databases are very good at. So that shouldn't be a problem. That's all I wanted to show you today. I hope you liked this video. If so, don't forget to click the like button and subscribe to the channel. This can help me a lot. Thank you very much for that. Thank you for your time. I'm Dr. Dror, and see you in the next video.